Now, come on, guys. What happened to you?
Listen.
What happened?
I'm trying to plus, sorry.
So who are you missing still? David, was it? Or who is? All right, he's coming then. Yeah. Okay. Right. So we're having a look at some questions that people have trouble with. So we're going to start with, we said, page 8, 3W. Yeah, 3W. So we had 9x plus 5y equals 0 and minus x minus 5 equals 0. Okay? So what I'll do is I'll just change that into 9x plus 5y equals 0 and minus x equals 5. Are you happy? I take that over to the other side. And then I'll multiply by 9. So that's a 9, and then 9 by 5, 45. And then what I'll do is I'll add 9x and 9x, or 9x and minus 9x is gone. Yes? 5y and no y's? 5y. 0 and 45? 45. So, no, I'm adding them. So, I'm adding them. Yeah? Yeah? We know what x is, actually. You can get the x from this guy. X is minus 5.
5.
Why
Minus 5.
Why negative 5? Oh, yeah.
Yeah?
Can I do it again?
Which part?
Yeah.
All of it.
I know. No, I can't do all of it again. It's recorded. You can watch it all again. Yeah? Because I know there's a few questions. I want to get through them all. Jafar.
My name is not Jaffa.
Sorry.
It's Jawahar.
Okay. Well,
Or just CG.
No,
huh?
it's only for you.
Person who is speaking Arabic, please speak English. Yeah. Okay. All right. I will do your question next now. Do you want to show it to me on the screen? This was an example I did in class with the red and the blue line one, wasn't it?
Hmm?
I said I'd do that one. It was in the parallel and perpendicular lesson, I think. Do you have it on your tablet? Can you show me it so I can do it again?
Blue line?
Yeah, that one you wanted me to do, yeah? I'll draw it again. So, what was it? I gave you, it looks like I gave you this green line here, which was y equals 10x minus 2. Oh yeah, and then I had a red line which was perpendicular, and then I had a blue line here, like that, which was perpendicular, and I wanted the blue line, wasn't it? Come in! What happened to you? Okay, I think I got all the info. Yeah, I do. Yeah, I'll do that one now. Okay. Do you remember? Do you remember we did this one earlier in the week? Yeah, we'll have a look at this one again as another example. Oops. Come on, guys. Come on. Maybe it'd be better to sit elsewhere because it'll be easier for you to see, right? Yeah, like for example, that looks like a great place to sit and see. Yeah. Now, unfortunately, you won't be sitting beside great people. But at least you can see the screen.
Just how many ones.
All right. Are we ready to continue?
Yes.
Yeah. Now, the real question you need to be thinking is, in that table, who am I thinking is not a great person? That's one to sleep on tonight and to think about. All right. I'm just joking, of course. Right. Let's have a look at this one here. So, what is the slope of the green line? Well, if you want to make it a little bit clearer, you can say y equals mx plus c. It's the same thing, right? But what's the m?
-2.
It has to be minus 2.
And the y is 10.
This here
Yeah.
is 10.
Yeah.
Now, so you're happy with that part, yeah?
Yeah.
Now, the next part, if I have one line here, and then I draw a line that's perpendicular, and then I draw another line that's perpendicular, these two, they must be parallel. They have to be.
Yeah.
They have to be.
Okay.
So, it means that the slope of this blue line has to be minus 2. It has to be. Okay? Now, here comes the tricky part, I think. So, what is the slope of the red line here?
1/2.
A half. A half, yeah.
Yeah.
Now, just be really clear what that means, okay? I just remind you of the meaning of slope. If I say to you the slope is 2, that means when you go out 1, you go up 2.
Yeah. Rise over run.
Rise over run, exactly. If I said the slope is 0.5, meaning a half, it means when I go out 1, I go up
Half.
0.5. Okay? That's what it means. Yeah?
Why? Why?
Yeah? That's the meaning of m. Or to be a little bit clearer, if I said m is a half, that means you would have to, another way to think about it is you have to go out 2 to go up 1. But I kind of like thinking about it this way.
Yeah, this
Yeah?
one is better.
Yeah, it's a little easier.
It's
Yeah.
not confusing.
So if m is a half, if I go out 10 units, how far up will I go, for example? If m is a half,
Why?
5, as an example. That's what you're only going up half the height.
Yeah.
As this one here. So let's go back here. Okay. Now look, think really carefully. This here has a slope of a half. Okay. This piece here is 10 units. So how much was this?
10.
No, it's a half.
20.
No.
20.
Again. Why is it 2?
Huh?
Why is it not 5? 8.
Because 5 would make the slope 2. I mean, if you said it was 5, then that you're saying you go out 5 and you go up 10. That would make the slope 2. If you go out 20, it's a half, yeah. If you go out 20, then you should go up 10.
So it's like
Half the
10
amount.
by 2.
Yeah. At times by half. Yeah. Like, here. This is 20. This is 10.
No.
How many times is this compared to this? It's half the amount, isn't it?
Yeah.
Yeah. So, that's what I'm saying. If the slope is a half, it means if this is 10, then this was 20. You need this to be half the amount here. Yeah? Are you sure? Are you sure?
Yeah.
That wasn't a confident yeah, but it's okay?
Yeah.
Okay, fine. So if that's 20, what's this point here? Minus 20, comma 0. Because you went 20 backwards. Yeah? So, I can use that point with this. Y equals mx plus c. Oh, sorry, no. Yeah. And I put this point in. 0 equals minus 2 times minus 20 plus c. So, what's the c? Minus 40? I think. It's minus 40, isn't it? Yeah? Because this is 40 to the other side. Right?
Yeah.
Yeah, so the answer is y equals minus 2x minus 40. Yes.
Yeah.
What?
From where did you get the force in front of
2 times 20.
Oh, okay.
Yeah? What's wrong? Is it okay or not? Okay? We can do more questions now. Whatever we need to see. Yeah. You can also write this down and you can watch it again later too. And if it's still a problem, we can do it next week again too. No problem, whatever questions you need to see. Sometimes these things you need to think about it, you know, and then maybe later it'll make a little bit more sense. Yeah.
How we get red line slope half?
Because the green line slope is -2. So it's perpendicular, so you flip it and change the sign. Yeah? So the -2 becomes a half. You know, to flip and change the sign. What is the next? Yeah, go on. Is it okay or not?
Yeah.
It's okay. What's the next question we need to
I
see?
have a question.
Yeah, which page?
I didn't about the third.
Oh, is it a question from the book or is it an example I did?
It's an example you get.
Okay, what's the example then? Can I scroll down? Yeah.
Yeah.
Yeah, which example is it? This one. This one here?
Yeah.
Yeah? -84 plus root 756 over 14 plus root 189. Okay, we'll do that one now.
What is that?
It was an example I did in class. Okay, let's have a look at this. It's an
They gave us.
yeah, yeah, it's an example I did in class. I think it is in the book too, but anyways, here it is. So the first thing I need to do is have a look at 756. What can I do with that?
Multiply
Seven.
by the 14.
You can do it 14?
No, not 14. The square of the 189 minus 14.
Ah, what are you saying, man?
That's man.
Not man?
24.
You're 17, aren't you? Yes? Okay, what are you saying, boy? Right. 756. What numbers go in? Well, 2 definitely goes in. Okay, so 2 and 3, 7, 8. Okay, well, look, okay, we could have done 4, I guess, because 2 goes into this again. Tell me, can you divide 756 by 4?
Yeah.
You can?
Yeah.
Can you divide it by 8?
Nope.
Okay, let's go with 4. 4 and
189.
189. Oh, nice. Oh, so I guess 189 can't be broken down, or can it? No, you can do 3, can't you?
Yeah, 2, 5,
3 and
Yeah.
252?
We don't really need it because we like have square root of 180.
No, but I would like to break it down. Because I can break the 189 down, it looks like. Does 252 break down?
63. Lots of facts.
What's 63?
189 divided by 3.
Yeah.
Oh, sorry, yeah, not 252. That's ridiculous, yeah. 3 and
63.
63.
Yeah, that's
63 is 3 and
That's what
21.
Yeah.
And 3 and 7. 3. So I think this is 84 plus 3. There's only one pair, isn't there?
So
Yeah.
3 and then whatever 4 times 3 times 7 is 21, 40, 83 root 84 or something.
321.
Because you can change 756 into 3 squared times 4 times 3 times 7.
Yeah.
That when I look at it. And I can also change 189, well, into 3 squared by 3 by 7. Oh look, 4, what am I doing? 4 is 2 squared. 2 squared. I forgot to break down the 4. Okay, that's nice. So that means that's 84 plus 3 times 2, 6 root 3 times 7, 21, and then 14 plus 3 root 21. Okay, that's as much as I can break it down. This is what I was getting at. I wanted to simplify the numbers as much as possible. So now it makes it a little bit easier to multiply by the conjugate. Minus 84 minus 6 root 21. No. Sorry. 14 minus 3 root 21. And 14 plus 3. Good grief. Sorry, it's been a long week. 14 minus 3, 21. Called the conjugate. Yeah.
Have another question.
Yeah, go ahead, yeah. What's the question? You want a point? Yeah. Hmm?
And page.
Oh, I'm not finished this one.
Oh, you're not?
Ah, no, there's much more to go. Much more to go. Right, we'll need the calculator for sure, because there's some big multiplications here. 84 times 14, what's that? Minus 1176, and then minus 256, is it? Root 21? Sorry, 252 root 21, and then 6 times 14? 84, thank you. And then the last one is minus 18 times 21. What's that?
Minus 8. No. Oh. It's 84 root 21.
Ah, no, the root 21's gone. Because it's root 21, root 21. What is it?
378.
Yeah, that seems believable. And then on the bottom, you'll get
196.
196, and then what'll happen is it'll be minus a piece and then plus a piece, and the middle two cancel always. So then we can just jump straight to the last one, which is minus 21. No, minus 9 times 21. What is it? 189. Okay, so on the top it's gonna be minus 1176 and minus 378. So that's gonna be minus something pretty big. 1554. I think I lost the root somewhere, didn't I? When I multiplied out the top, I lost the root 21, did I? That, by that, is that, by that is root. Oh, it was this one. It should have had a root 21. It should have been a root 21 there. I just didn't write it down. Okay, so minus 252 root 21 plus 84 root 21.
168.
Root 21. And then 196 minus 189 is 7, isn't it?
Yep.
And I'm sure 7 goes into both of those numbers.
Yes.
7 goes into that, minus 2, 2, 2. And then
Plus 48.
I think it's a minus 24 root 21. Okay, that's that one.
It's 40.
I have a question.
Yeah, I got 48.
For which part?
That's 7 minus
It's
square root of 30.
negative 84 times square root of 21.
Let me see. For this third one?
Yeah.
Yeah, it was minus 84 times... Oh! That number's wrong, isn't it? Yeah, minus 84 times 3 root 21.
Yeah.
Yeah, what should it have been? We can fix it.
Yeah, it will be 1154. 1154.
Are you sure? No, I don't think so.
252.
That's too big.
Yeah.
84 times 3 root 21 is...
Yeah.
252.
What is it?
Minus 252.
252.
Yeah.
Root 21.
Yeah.
Yeah.
Okay,
84 times 3 root 21.
negative 3.
Well, yeah, minus. I put the minus in.
But
No, it is 8. You did 6 times 14 to get to the 84.
Plus 252.
84. Oh, which one are you doing? Okay, let's just have a look at the 4 of them again. Right, let's just look at the 4 of them again, make sure we're right. Okay, so the first one is minus 84 times 14.
okay.
That is minus 1176.
Yeah.
Yeah. And the next one is minus 84 times minus 3 root 21.
That's
Negative 252.
plus.
Plus,
Plus.
252 root 21. Is that what it is? You have the calculators? 84 times that one. Yeah. Then the next one is 6 root 21 times 14. What's that one?
That's 48.
84.
84 root 21. Oh, so I was right. That was 84 then.
Yeah.
Okay. And then the last one is 6 root 21 times minus 3 root 21, which is what? The 378, is it? 378?
Yes. Yeah.
Yeah. So
The point is there.
now if after scratching it out, minus 1176
Minus 370.
minus 378 plus 252 root 21 plus 84 root 21
Over 7.
over 7. Okay, so those two, well, that's still minus 1554. And is the next one different? Yeah. What's the next one? 3, 3, 6 root 21. And can they still, that can still be divided by 7?
Yeah.
Oh, this is the 48, isn't it?
Yeah.
Minus 222 plus 48 root 21.
Yeah.
Yeah, okay.
Can I ask
Yeah.
regarding the conjugate basis? Like, do you have to change the sign for the one with the root?
Always, yeah.
Only the root.
Only the root.
So, like, the whole numbers, you don't need to change anything.
So 48, I didn't change it.
Now just, oh wait, are we talking, sorry, I'm talking about the last step or earlier?
Like the red one? Like,
Yeah.
Do you have to change
Just the sign on the tree, on the root part.
Oh, so the other part you just...
No, yeah, the other part stays as the 14, yeah.
Oh.
I don't think, if you change the sign on the 14, I don't think it'll work. I don't think the terms will cancel.
It should be 252 square root of 21.
I don't think they'll cancel.
I think
They won't cancel.
Radian maybe.
In fact, they'll add together. Yeah.
I should get 252
Yeah.
square root of 21.
Right, what do we need to see next?
The proof question.
Which one?
This one.
From earlier today?
Quadratic.
Which one?
Uh,
The one you tried?
no, the example.
The proof. You want to do another proof one?
Yeah.
Yeah, okay.
It's the same one. Yeah. I still can understand the concept, the logic.
Yeah.
Square root of 21. It should be
Which one will we do?
252.
Will we do 4A maybe? Or what number is it? 6A. Because of the minus? Yeah. So that will be always negative. We need to prove that that's always negative. Yeah, okay.
Wait.
Okay. Well, we're just going to do this one in a
No, no,
minute.
no. See, I told you that I got this number, right?
Yeah.
But this one the same. So is it okay if I put this number here
No.
instead?
In the exam, they want
That
this
part.
number.
How do you know?
How do I get it in the calculator?
What do you mean? Which number?
When I multiply negative 84
Let me see. Yeah. What is it?
Negative
84.
times
Yeah.
minus 8 minus 3 square root of 21.
Ah, I see. The calculator is giving you a decimal. So, well, you can just see it's going to be 84 times 3. That's the 252. And you can just keep the root.
Oh, okay.
You can do it that way.
I bet I can't do it this way?
Yeah.
Oh, okay.
I don't know how it works.
Okay. No, okay.
So, how do we supposed to know that the quadratic equation is always positive or always negative?
I have a question.
Easily. I'll show you now. Yeah? Well, I'm just going to do page 14 now.
But wait, I have a question. Like it's the same.
Yes. But is it the same example?
No, just like
Yeah, we can come back to it, don't worry. Don't worry. Page 14, question, what did we say? 6F, is it?
Yeah.
14. Yeah, today.
Now, I tell you, are we listening, guys? I tell you that all these quadratics, they're either always positive or always negative. Meaning, well, just that if you put any value of x in, the answer will be either always positive or always negative. I don't tell you which, and like you said, you need to figure out which it is. So what happens if I put x as 0? What do I get here? Negative 16. So is this likely to be always negative or always positive? Well, I couldn't have meant it's always positive, could I? Because we already have one value that's negative. So it must have been that it's always negative. Now, of course, that's not proof that it's always negative. Just because when I put x as 0, it's a negative, that doesn't mean the answer will be always negative. Right? But so let's try and prove it's always negative. So I want to prove that this is always a negative. Okay? Let's clean it up first. What is a common term? 2. Or rather, minus 2. Yeah? But no big deal. If you want to multiply, well, which would you prefer to do? 2 or minus 2? Minus 2. So, this becomes x squared. What does this become?
4.
Yeah, minus 4.
Negative 4.
And this one? And then here? More than 0. Why?
Because we changed
Signs.
We divided by a negative. When you divide by a negative, it gets flipped around. Yeah? The inequality sign flips when you do two things. Divide by a negative or... What's the other situation? The inequality sign flips when you divide by a negative or... Yeah, tell me.
Or we transfer.
Yeah, or we...
negatives to
No,
zeros.
no, not then. It stays the same.
Oh,
When you
signs.
multiply by a negative.
Uh,
You know that. You learned that in school.
which exercise is it?
Huh?
Which exercise is it?
This is page 14, 7, 6F.
F, not A.
Yeah, we want to do F because of the negatives.
Alright.
Yeah?
Doesn't matter what inequality sign you start with.
Oh, you mean if you started with more than 0? Yeah, no, that is not right because you couldn't prove that it's more than 0 because it's not more than 0. If you said that this is more than 0, I can prove you wrong by saying, oh yeah, well what happens when you put x as 0? You get minus 16.
So we start less than 0.
You have to, there's no choice. Yeah.
No.
So how do you know which one to
X
start
equals
with?
0.
Ah, that's what I was saying at the beginning. If you put x as 0, what value do you get?
Negative
Yeah,
16.
yeah. So it must be that I'm trying to prove it's always negative.
So it is based on the C value.
Well, I mean, that's just a rough way to figure out which one it is. But like I said, that doesn't prove it's always negative. I'm doing the proof now. But if I started off by trying to prove it's always positive, I'd be wrong straight away. Because I just need a student to say, well, what if you make x as 0? Then the proof is over. It's obviously wrong, you know. Can I continue with this?
Yes.
Yeah? What's the next step here? Completing the square. Which is x minus 2 squared.
Yeah.
Next. Plus 4. Now, this is always bigger than or equal to 0. Right?
Yeah.
And this is always more than 0. Okay? The number 4 is always bigger than 0. Right? Because it's, you know, the number 4. Yeah?
You got rid of the negative 2 from the...
Yeah. I divided everything by minus 2. Yeah? Yeah? Now, what happens when you add a number which is always more than 0 with a number that is always more than or equal to 0? What will the result be? The result is always more than 0. So that's the end of the proof. What's confusing here?
When the x was 2 squared.
Yeah.
The logic after this.
Yeah.
Right. Is it true to say that this piece is always more than or equal to 0, regardless of the value of x? Yeah. Right? How do I get the 0? What value of x would make 0 here? 2.
2.
And if I put in a value of x which is not 2, will I get a positive or negative? Positive.
Positive.
So, because it's a square.
Okay.
So is it true to say, no matter what the value of x, this piece here will be more than or equal to 0?
Yeah.
It's true.
Okay.
Could it be negative? Could it?
No.
No, why not?
Because I have squares.
Good, okay. Is the number 4 a number which is bigger than 0?
Yeah.
Yeah, don't think too hard. It is, yeah, okay. So, I have a thing which is more than or equal to 0, and I have a thing which is more than 0. And I add those two things together. The result has to be more than 0.
So,
Yeah.
So,
it's always
I mean, it
all
makes
positive.
sense
always
when you think
positive.
about it. Yeah. This proves the first statement, because I ended with a statement which is always true.
But by the above
And
one,
divide
the first
to
one is
4.
less than 0.
I know that.
Huh?
I know that.
Oh.
Okay, so this quadratic equation is always positive.
No, it's always negative.
I divide by negative 2.
Yeah.
Okay, but it's x squared minus 4x plus.
I'll give you an example to clear your mind in a moment, okay? Yeah.
Then we get like 2 the half of 4 is 2 and 8 minus 4 is 4.
During the calculation, you get an answer. So you just prove that because you put the answer at the end, that the statement at the beginning is correct.
Yeah, yeah. No, I know there's a couple of people confused on this. We'll clarify it now. Can I scroll to the side?
Yes, yes.
Yeah. Yeah.
just
1 sec, okay, yeah. No, we're not thinking clearly. We'll clarify it in a moment now, okay?
So, one more question.
Yeah.
For the thing we say, we always say that positive or negative, is it x value or y value?
The y value, if we're thinking about it like this, yeah, because it's the quadratic. Yeah. Can I scroll to the side?
Yeah.
Yeah. Okay. So I need to. I'm trying to think of a good example just to clear your mind. Let's see. I'm going to pick a silly example, but just to make it clear, just a silly example, okay? So I suppose I want to do something like I want to say prove that the ground is wet, for example. Just a silly example. I want to prove the ground is wet. This is a little bit like I want to prove it's negative or whatever it is, okay? So we'll start off by saying something like the ground is outside, something like this, okay? And outside, it's not raining or something like this. But let's say last night it rained, and let's say it took it takes let's say 24 hours for the rain or to the ground to dry. 24 hours for ground to dry. Now, let's say you agree with me. It takes 24 hours for the ground to dry. Let's say that's true. And then let's say previously last night it rained. That statement is true. And let's say outside it's not raining now. Okay? Is it right for me to say, and the ground is outside?
No.
Is it right to say the ground is wet?
Yes.
It is, yeah. Is it raining outside?
No.
No. This is kind of what I hear when people say this. The result is positive, and then they mean, but at the start you said it's negative. The relationship, I'm not saying that this is the same as this, you know. I'm putting together a bunch of statements. As long as you accept each statement follows from the previous, and each of them is true, then the first one must have been true, you know. Like, it'd be like me saying at the end of this, therefore outside it's raining. You know, it doesn't link up like that. All I know, you get what I'm saying? Like, it's not about I am saying that this is the same as this. I'm, like I think you were saying earlier, I've gotten to a statement which is definitely true, no doubt about it. So that meant this one must have been true, and so this one must have been true. And I can go backwards saying, well, the original must have been true. You know? Yeah.
So the answer is always positive?
Oh, my heart.
Wait, no, because the answer in this book says always negative.
Well, maybe that's just a typo then. What's it, 6F? No, it says 6F always negative.
Yeah.
And that's what I proved. It's always negative.
You proved it.
It's always positive.
Ah, no, I've just explained now. Right, I want you to watch this. Can I scroll to the side? I'll do it another way. Right? Okay. Is 4 more than 0?
Yeah.
Yes.
Okay, now stay with me. Is x minus 2 squared more than or equal to 0?
Yeah.
Okay. So would x minus 2 squared plus 4, would that be more than 0?
Yes.
Okay. Still with me? There's no one who wants to object yet. Okay, because once I get to, if you agree with every statement and I get to the end, then you can't suddenly object. You have to object at a particular point. Okay? Right, I'll expand this. That's okay? Right? So that's x squared minus 4x plus 4 more than 0. We're still agreeing?
Yes.
Okay.
No.
What's wrong?
Yes.
Okay. X squared, x squared minus 4x plus 8 more than 0. Right? Now I'm going to multiply everything by a number. Am I allowed to do that? Of course I am.
Yes.
Let me multiply everything by 2. 2x squared minus 8x plus 16 more than 0. Right?
Yes.
Right, let me multiply everything by minus. So what does this become? Minus 2x squared, and this one plus 16x, and this one. No, you confused me. I'm multiplying by minus. Don't confuse me. This one is 8x, and this one minus 16. And then what happens when I multiply by minus?
Same sign.
Yeah. So is this is true?
Yes.
Yeah. So all I've done was I've just done the original proof, but just backwards. That's all I've done. All I did was started here and went up. In this proof here, I started and just went the other way.
So it's
But of course that
always
doesn't
negative.
matter.
Oh, so like, the question, we don't really need to solve it.
So it's always negative.
So I'm confused.
So it's always negative. Yeah?
Yeah.
It doesn't matter that this is different to this.
Because it's always negative.
You get it. Do you know, it doesn't matter about the direction. If I say A proves B proves C, then it's also, you know, in this case, C leads to B leads to A. Like, you're all happy with this direction. But this is the same, it's just in the opposite direction. It doesn't change anything. Yeah. Yeah. Some of you have accepted this now. Okay. Right, what's next? What's next now? What do we need to see? Oh, no. We'll have to wrap it up there. I guess this one took up much more time. So look, whatever questions you didn't get to see that you really want to see, we can do it next week then, okay?
Yeah.
Maybe we won't get so stuck on one question.
I have a question. We can't find this on YouTube.
What do you mean?
The timetable for the
Oh, this is on YouTube. All the videos are on YouTube.
The same? Are you sure?
One of the
right?
changes.
Yeah, you just
Yeah, on my YouTube channel. Yeah,
Sunday night.
guys, you two, and her as well. Jafar? Yeah. Yeah. Oh, there's 3 syllables. That's okay. Anyways. Apologies. So look, you two have an extra tutorial next week, okay? So, were there some questions you still wanted to ask? Yeah? Were there some you still want to ask? Yeah, just ask them in the tutorial, the extra tutorial. You'll get them covered, okay?